Okay, good morning. Welcome to the course EE404 Radar Systems. My name is Ali Kara, and teaching assistants will be announced later. Okay, here is the topics that we are going to study throughout the semester. First, we introduced radar systems, some basic radar parameters, and operation of radars. Next, we will spend 2 or 3 weeks for radar range equation. First, we'll be giving the simplified version of radar equation, and then we will extend it, and we'll get a quite complicated radar range equation. Then 2 different radar types will be studied in detail. These are moving target indicator radar and pulse Doppler radar. First, we'll be giving general operation of these radar systems, and then we will look at signal analysis. What kind of receiver structures or signal analysis techniques are used in MTI and pulse Doppler radar. Then we'll be looking at the tracking radars, operation of tracking radars, types of tracking radars, and their comparison. The last 2 subjects will be on radar signal processing and signal detection. This is basically receiver design and channel effects. So overall we have 8 topics, which might take typically 9 to 10 weeks. Okay, depending on the on your performance actually. So the course material will be following Skolnick's book, Meryl Skolnick's book, which is very popular and widely used in many universities in the world. It's the 3rd edition that we'll be using. There is also 1st and 2nd edition, and the problem numbers might be different in different editions. So you have to be careful on problem numbering. The reference book will be Mahafzad's book, which is again very popular. It is actually on how to use MATLAB for radar system design. Basic concepts are very similar or almost the same as Skolnick's book, but additionally, in this textbook, you can see some MATLAB codes and MATLAB routines or scripts that you can use for understanding of the radar systems and radar parameters. As usual, we'll be giving lecture notes, PDF material. Probably you will see video lessons, but this is not finalized yet. Okay, how about the prerequisites? I assume that you passed communication systems course, RF and microwave engineering course, and probability and random process course. These are must for this course. If you did not take any of these, then please drop this course. Otherwise, it's very likely that you fail. If we go into the details, basically, we should have some knowledge on probability and random process and signal analysis, specifically transform techniques, so in time domain and frequency domain signal analysis. And finally, electromagnetics, where we study some RF components. Is there any question so far? Okay. Course learning outcomes, CLO. This might help you to actually identify which topics are more important and will be asked in examinations. Describe operation of radar systems with the basic transmitter and receiver components. Describe radar signals in time and spectral, so frequency domain, and its main design parameters. Derive a simple radar equation with receiver noise, and describe range ambiguity. This is not correct. Ambiguity and speed ambiguity. This is the correct version. Speed ambiguity, and compare various radar modes such as pulse Doppler radar and MTI radar. Compare various tracking techniques in radars. So we got some tracking techniques that you are supposed to know and compare them. Calculate main parameters of a radar system for a given mission or requirement. So at the end of this course, you will be able to do all of this outcomes. Okay, how do we proceed? What is the method that we are going to use in teaching this course? We have several types of quizzes. We got online quiz and in-class quiz. Okay. First of all, let me tell you something. From educational point of view, I believe that classical midterm and final examination based system, I mean, you study only for midterm examination and then final examination. There is nothing else that you have to do, or there is just there are several homeworks. I do not believe in this system, this classical system. Instead, I believe that the material will be assessed continuously. You have to study something and then you will be evaluated. You will be examined whether you studied or you learned that subject or not. And we have to do this continuously, so over the semester. Okay, this means that there should be many different assessment steps, so examinations, small low-stake examinations, and typical these are quizzes, of course. So in my system, there will be many quizzes at different stages, and you are supposed to study continuously, okay? Continuously. For every topic, you have to study and then follow the lesson, and then you will take a quiz, okay? Now, from this point of view, we see online quizzes and in-class quizzes. Online quiz is called pre-test because it's given before the lesson. On the other end, post-test is in-class quiz, which is given after the lesson. So what you are supposed to do is simple. You study PDF material by yourself. Okay? You know, in this century, knowledge is not important. The important one is that you learn by yourself or not, and you know how to learn. If you are able to learn by yourself, or if you know how to learn by yourself, then you are good enough for this century. Otherwise, knowledge or information is not meaningful because it's everywhere. So then this system is based on the idea that you study yourself and try to learn by yourself. Not at all, not all material, but some basic materials can be learned by yourself. It's quite easy. The complicated parts will be left to the lesson. Is that right? Okay. So then we got some pretest. So you study PDF material And then you take this online quiz, which is multiple choice, and it might take about 20 to 30 minutes typically. And this quiz assessment grades will be contributing to the semester score, but not too much, little. So before the lesson, then you study the material, okay? And you learn some basic, simple concepts. So you are ready to the lesson. And the lesson will be easier for you in that way. Why? Because you are ready. You know simple things. And in the lesson, we'll give the complicated parts, and then you can easily learn the material, the concept. In class quiz or post-test, it's given after lesson. So this is just like midterm examination, but just one question or two question midterm examination, you can imagine. This is classical examination in the classroom. It's focused on single subject and typically single question with many parts, sub-questions. We typically give about 20 minutes or 15 minutes, depending on the question, sometimes 25 minutes. And it contributes to the semester score, the passing grade, greatly, okay? It's quite important. So how about the laboratory works? As you know, this course is 2 to 3. So we got 2 hours theory and 2 hours lab. So lab is very critical for this course because this is about hardware actually, and we got some lab facility, platforms and models where you can build your own radar. There are 8 to 10 experiments or demonstrations. Most of them are demonstrations. So we build up and then show you how it works and ask you whether you understand the operation or not, or we allow you to build it and then demonstrate that it works. Experiments will be announced weekly. So we'll be announcing next week's laboratory and give a manual. Basically, there are 2 groups of or 2 categories of experiments. One is modular radar design. This is step-by-step basis radar design. The second one is TI Texas Instruments radar platform. We have that platform. We have been using this for research purposes. And we'll use this radar platform for some field tests, some realistic target tests. So what are you supposed to do in laboratory? You first study the manual. This is typically 3 to 5 pages, very classical manual. And it's quite related to the content of this manual is quite related to the theoretical material, okay? And you will take an online quiz, which is basically on this manual. So whether you studied this manual or not, you will test yourself and you'll be ready for the laboratory. When you come to the laboratory, we'll again give a lab quiz, which is very small, and we'd like to actually test your readiness level for the experiment. Are you ready for this experiment or not? If you don't have any idea about the experiment, then you will learn nothing in the laboratory. So we have to know that you studied a lab manual and you are ready for the experiment. This is typically single question exam, 10 to 15 minutes. And in the laboratory, which is coordinated by the TA, teaching assistant, there may be a test system, there may be design or report. All activities will be announced for each experiment. Okay, how about the grading? We have theoretical part, subject-based, so these are topic-based. And this is for laboratory. These are general tests, okay? So the contribution of the midterm and final will be about 40. Okay, this is tentative, by the way. We might have slight change on this table. So for the topics, you should take online quiz, 5% contributes to the passing grade. In class quiz, post-test, which is 25%. So it's very, you see, it's equivalent to final examination. Okay, and online quiz in lab, 5%, and in lab quiz, 15%, and test demo or design or hardware, which is about the performance, your performance in the lab, it's 10%. Okay, so for topics, we have 30%, for laboratory, we have 30%, and for final and midterm, we have 40%. So quite, you see, equally distributed. You are supposed to spend time for all activities in order to get some, say, AA. Okay, the theory may not be enough. Okay, that's the end of the presentation. You may, if you want, you can, if you have any question, then I can take questions now.